Hello, this is a video over Chapter 1, Lesson 5 for geometry. Okay, today we're going to be looking at relationships between angles. So last class we looked at classifying angles and being able to know the parts of an angle and even some names for certain angles. Today we're going to look at relationships between two angles or more. So if something has a relationship, you've got to have at least one, right? You can't have a relationship with yourself. I would recommend that you take out your notebook and title this 1-5. And we're going to just go through a few examples of special angle pairs. So the first type of angle that we're going to look at are called adjacent angles. So adjacent angles, and I'm going to just use this symbol angles to represent angles instead of writing it all out. Adjacent angles are basically two angles that lie on the same plane and they have a common vertex. So the simple way of saying that is just that I have two angles that are side by side and they're touching. So remember we talked about this is the vertex. They don't have to be the same size. So last time we talked about an angle bisector, meaning it separates the two angles into two equal parts. Well, this doesn't necessarily mean they're exactly the same size. It just means they're next to each other and sharing the same vertex and a common side, okay? So we call these adjacent angles. So angle 1 and 2 here are adjacent. Another example could be angle 1 and 2 here. These are adjacent, and what's in common is the vertex and a common side. And so examples of non-adjacent angles means angles not on the same, sharing the same side, would be like if I had an angle here, that's my vertex there. It's not the best drawing. And remember, we name our angles by points that are on it, and the vertex is always the center angle, the center number. This is angle 3, let's say. So an example would be that angle ABC and angle 3 are not adjacent. Because if you think about it, angle 3 is engulfed within ABC. They're not sharing a common side. I mean, they have common, like they're sharing common spaces, but they're not next to each other. One's engulfing the other. So that does not work. This is not adjacent. Okay. Another example would be, gotta imagine this is a straight line. Got angle 3 here, and then I've got angle A, B, C here. So see how I've got, if I draw actually where the angle is, angle 3, and then angle ABC, they're right here. They're not touching, they're not sharing a common line that creates the angle, a common side. And so even though like here they're kind of sharing it and here they're sharing it, it's not the part that they both are having common and they're not side by side. So this is non-adjacent as well. So angle ABC and angle 3 are non-adjacent. Okay. So the next type of angle that we want to look at is called a linear pair. And so the name in itself kind of gives us a hint, a linear pair. So we've got two angles because it's a pair, right? And a linear pair just means a pair of angles that create a line. Or you could say that they are 180 degrees. So 1 and 2, angle 1 and 2 are linear pairs because if I measure out with a protractor how far this is and then how far this is in terms of angle measurements, add them together, it equals 180 degrees. So So a linear pair is a pair of adjacent angles with non-common sides that are opposite rays. So fancy way of saying it is just a linear pair, usually it has to be adjacent because it has to be, they have to be two side by side adding together to be 180 degrees. So they have to be adjacent and they have to equal 180 degrees or make a line, which is another way of saying 180 degrees. So see how this is a line right there. All right, another type of angle that we're going to see a lot this year are called vertical angles. And vertical angles are basically angles that are created from two intersecting lines. So I've got two intersecting lines and they are across from each other. So these two are vertical. You could even say that, use a different color here. You could even say that these two are vertical. So the green ones are vertical, the red ones are vertical. And what's interesting about vertical angles is that they are always congruent. So my red angles here, created by these two intersecting lines and they're across from each other, they're congruent. And then the green ones are congruent. So if I were to name this 1, 2, 3, 4, I could say 1 is congruent to, so angle 1 is congruent to angle 3. And I could say angle 4 is congruent to angle 2. So those are some cool things about vertical angles. Now, an example where it's not a vertical angle would be when you have some rays going out and they are not lines intersecting. They are literally just rays that meet at the center, and they're all, then you have angles across from each other. So an angle like here and here, these are not congruent because it's not two intersecting lines creating those angles. Even though they're across from each other, the rays meet in the middle, but then they go out in different directions. They're not intersecting. They're not two lines crossing over. So don't be mistaken that just because you have two angles across from each other, they're congruent. Doesn't necessarily mean that. They have to be intersecting. And they have to be intersecting for it to be a vertical angle. Okay, so let's take a look at our study guide. If you don't have that, pause the video and get that printed off. So let's take a look at some examples here. Name an angle or angle pair that satisfies each condition. So two adjacent angles. So we want two angles that are side by side. Literally any angle that's side by side would work. So I could say angle RTL and LTN. And remember, we named the angles by the points on the line and then the vertex in the middle. So you could literally do so many different ones. You could do LTN and NTE, or you could do ETS and STR. Like there's so many combinations, right, of two angles that are side by side. Number 2, an acute vertical angle, two acute vertical angles. So remember, acute means less than 90 degrees, right? Less than 90 degrees. So literally, this is acute, this is acute, this is acute, right? Two acute vertical angles. Now, we need them to be vertical, right? Vertical, meaning across from each other. So if you think about this, I've got a line here and a line here, and they are intersecting, which means the only acute angles that I have that are also vertical are these two angles, which means the angles, two acute vertical angles would be RTS and LTE. Okay, so it has to fit both these two descriptions, acute and vertical. All right, number 3, two supplementary adjacent angles. Oh, I didn't talk to you about complementary and supplementary. So let's go back down here, and I might have to actually add it up top here because I'm running out of room. So supplementary angles basically just means two angles that add up to be 180 degrees. So that includes like linear pairs that would work. So angle 1 and angle 2 are supplementary. And supplementary angles. So two angles that add up to be 180 degrees. Complementary angles are two angles that add up to become 90 degrees. So angle 1 and angle 2 here are complementary. So I like to think about it as when you're giving someone a compliment, you give them a thumbs up. And when you give them a thumbs up, you look at where your thumb is to where your pointer finger is. It creates a 90-ish, 90-degree angle. And so that's my complementary angle, 90 degrees right here. Okay, so two supplementary angles, basically two angles that add up to be 180 degrees. So in some ways, it's also looking at a linear pair. So like this right here is a line, that's 180 degrees. This would be 180 degrees. So I could say STR and RTL are supplementary angles and adjacent, they're touching. I could also say RTL and LTE, because then that would be right here, and that would be supplementary or 180 degrees. So there's lots of, I think those are the only two options for you to say supplementary angles would be those two combinations. And then number 4, an angle supplementary to RTS. So this means that when you add this other angle to RTS, it will equal 180 degrees. Well, I don't know the other measurements of the other angles, and so I really can't guarantee that it would be adding up to 180 unless when I look at it, it makes a linear pair. And so an angle supplementary to RTS could be STR, like I wrote above, or it could be ETL or LTE. You could say it differently, right? LTE. So either one of those would be supplementary to RTS. Okay. Identify two obtuse vertical angles. Ooh, we've got a lot going on here. Two obtuse vertical angles. So I'm looking at two angles that are across from each other created by two intersecting lines. So if I think about this, I have a line here and a line here, and they're intersecting. And so the only obtuse angles that I see are right here and right here. And so I think that's my only answer. That would be TNR, so angle TNR, and UNS, angle UNS. That would be my answer. Identify two acute adjacent angles. So two acute angles that are side by side. Adjacent means touching and side by side. So I could do anything that's less than 90 degrees. And I don't know. I think this would be these two angles would be my only option that's less than 90 degrees. And maybe because I drew on it, it's kind of hard to see the lines. Let's see if I can erase those lines. So almost there. Let me erase those. Oh, yeah, that's right. Two acute vertical, sorry, two acute adjacent angles. So that each angle has to be smaller than 90 degrees. So these two would work, right? These two could work. These two could work. I think this one might be greater than 90 degrees. This one, these two could work, right? So any two combinations where each angle is less than 90 degrees will work. So I could say TNV and TNV and VNR, as long as they're touching and they share the same common ray in the center. Number 7, identify an angle supplementary to TNU. So TNU is right here. And it has to, when you add this other angle to this, it has to be 180 degrees or a line. So a good way to see if something is 180 degrees is that it makes a line. So you could use either this angle here or because it creates that line, and I probably shouldn't use that highlighter, but could use this angle here that makes this line, or I could use this angle here that creates this line right there. Hopefully you can see what I'm doing. It's starting to get messy a little bit. So supplementary to that, I'm going to say either UNS or angle TNR. Okay. All right, find the measure of two complementary angles if the difference in their measure is 18. Okay, so this has to do with our own kind of thought process in this. Find the measures of two complementary angles if the difference in their measure is 18, meaning I want to find the measurements of two angles, angle 1, angle 2. To put together, they need to be 90 degrees. And when you subtract them, it has to be 18. So angle 1 plus angle 2 has to equal 90 degrees. And when I do angle 2 minus angle 1 has to be 18. All right, so this one way of doing this could be giving it a variable. So x plus y equals 90. And then y minus x equals 18. So I could actually combine these equations by subbing in the value of x or value of y. So I could add x to both sides, and this would become y equals 18 plus x. And then I could plug, because I now have a value of y, I could plug this into my equation up here, and then I would have x plus 18 plus x equals 90. And now I have x plus x, which is 2x, plus 18 equals 90. So I'm going to subtract 18 from both sides. And so now I have 72. So 72 divided by 2 is 36. And so one angle would be 36. And so if I knew one angle was 36, then the other angle would have to be 90 minus 36, right? So if like this was 36 degrees, then the other one would have to be 90 minus 36. And that would be 54. So angle 2 would have to be 54. And then now we can check, subtract the 2. So 54 minus 36. Is that 18? It is. It equals 18, so that works. That was kind of a tricky one. This is like our little riddle problem. So I don't know if you'll do one like that on your homework, but think about how you can use your variables to represent your unknowns and then sub in one unknown, replacing it with an expression into the other equation to solve. Okay, so now we're going to look at perpendicular lines. Well, perpendicular lines are like basically lines that create perpendicular angles, right? So anytime you have two lines that create a right angle, they are called perpendicular lines. And we can use this little perpendicular symbol to show it's 90 degrees. Another way of looking at that in like a sentence, if this were line L and this were line M, I could say that line L is perpendicular to line M. So this little symbol here means perpendicular. Okay, so we all know that perpendicular angles measure 90 degrees. We can use that to now help us find missing parts. So I think I'm only going to do a few of these with you because I think this video is getting kind of long, but I think once we do a few, you'll catch on to it pretty quickly. Now we have given certain amounts, like a picture here, and this shows that these are perpendicular. Now, if I have two lines that intersect and they create a perpendicular angle, that means all the other angles created are also perpendicular. So these are perpendicular, these are perpendicular, these are perpendicular. So for example, here I have these two lines intersected. Well, if I know that this is perpendicular, then I know that this here, MSR, has to be perpendicular, and I know NSQ has to be perpendicular, and QSR have to be perpendicular. So now I can use that to my advantage. I'm using one truth to now relate to another thing that I can see to be true. So find the value of X and Y so that NR and MQ are perpendicular. So basically, we just have to find X and Y here. So I know that MSN are perpendicular, which means it's 90 degrees. And then this angle here is adjacent to it, and it creates a straight line. So I know they're supplementary, or they're a linear pair. And I know that it also has to be 90 degrees. So I can just do 90 equals 9y plus 18. So work this out. Now I'm going to make my pen a little bit smaller. Subtract 18, 72 equals 9y, divide by 9, y equals 8. So y equals 8. Then to find x, I know that this is 5x, this is x. So to find x, I could say 90 equals, well, aren't these two complementary angles? They add up to be 90 degrees. So 5x plus x equals 90. 90 equals 6x. Divide by 6, divide by 6. This would be 15. X equals 15. Find the measure of angle MSN. MSN. Well, the measure of MSN would just be 90 degrees. All right. Let's jump to number 4. And I might do 4 and 6, and we'll end there, okay? So measure of EBF is, so EBF is right here. That is 7y minus 3. And then FBC, so this right here, is 3y plus 3. Find the value of y so that these two lines, EB and BC, are perpendicular. Okay, meaning these are perpendicular, making a 90 degree angle. So I know that basically they are adjacent and complementary. So 7y minus 3 plus 3y plus 3 equals 90 degrees. Well, negative 3 plus 3 is 0, so that cancels out. Then I have 7y plus 3y, and that's 10y equals 90. Divide by 10 on both sides, y equals 9. Okay, let's jump to number 6. Find the value of y and these measurements, okay? Measure of angle RPT and TPW. So looks like I might just have to find what y represents first before I go any further. So it looks like I've got two intersecting lines and they create a perpendicular angle, a 90-degree angle, and these two are vertical, meaning this across from each other should also be 90 degrees. So I can say 4y minus 5 plus 2y plus 5 equals 90 degrees. And all right. Okay, so combine my like terms. 4y plus 2y is 6y. Negative 5 plus positive 5, that cancels out to be 0. Okay, divide. And that becomes 15. So y is 15. And then now I need to plug that back in to find each measure. So RPT, that's right here, RPT. So I'm going to plug in 4 times 15 because I'm going to use this equation here. So 4 times 15 minus 5 equals angles RPT. So 4 times 15 equals 60. 60 minus 5 is 55. So if one's 55, how could you find the other one if they're complementary and adjacent? Well, can't you just do 90 minus 55? So TPW is 90 minus 55, or you could plug in 15 into the little expression there and find it. But I'm going to subtract, and I believe it's 35. So angles TPW is 35. Don't forget to put a little degree sign there and this degree sign. All right, that's all I have for you. Let me know if you have any questions, but I'll see you next time.